That is good. Anyway, we have started late because I was running up and down. You know, I took my baby to Copic Hospital. So the whole day I was just there, you know. That's why we have started late. Okay. Anyway, away from that, CISCO managed to give us new modules, new slides, you know, which came yesterday. So if you remember properly, I said that, you know, would start using old slides, okay, because these new slides were not available, okay, but now they are available. As you can see here, you know, this is module 4, unlike those slides where here it was supposed to be chapter 4, okay? So they decided to be using module instead of chapter. Okay, so module 4 looks at Linux overview. All right.
Sir, let me just take you back, sir.
Yeah.
So what you're saying on our portal, we'll find these modules, eh?
The modules, they are already there.
Okay.
Your material, you know.
Yes.
Is already in modules.
Okay, right.
Yeah, so they just took long to release these slides, okay, the PowerPoints.
Oh, okay, I see.
Yeah. So the PowerPoints, of course, they are only for instructors, okay?
Okay.
All right,
okay.
So now, Linux overview. So Linux is another operating system. Okay, we looked at Windows. Okay, in module 3. In module 4,
yes.
at Linux. Okay, now I know most of the people, they know Windows. You know, they don't know much about this other operating system called Linux. Okay, so in security, very, very important that you know how an operating system works. So last time we looked at an operating system called Windows. Today, we're looking at another operating system called Linux. All right. Now, Linux is, you find that most of the tools that we use in security, in networking, they work only on Linux. You know, why? Because Linux is open source. That means that you can get the code for Linux and change it, or you get the code of Linux and make a certain software that you want. So you see, in such a way, you're not going to be restricted. So you can make any program that you want because you have got access to the code of Linux. Okay. So when you compare Linux to Windows, you find that Windows is closed. Okay. Microsoft will never going to give you access to the code. No wonder there in Windows, we have limited tools, but we've got more tools in Linux. Okay, so Linux overview is our title. What is the main objective here? The main objective is to implement basic Linux security. Okay, so what we have, of course, here, these are some subtopics, and then these are the objectives per topic that we are going to achieve. So you see, Linux basics. At the end of this title here, you'll be able to explain why Linux skills are essential for network security monitoring and investigation. Okay. Working in the Linux shell, here you'll be able to use the Linux shell to manipulate text files and so on. Okay, so we'll start with Linux basics. So of course, what is Linux? Linux is an operating system. Okay, now what is an operating system? Okay, an operating system. Okay, this is the software that we have running on our laptops. Okay, and making us to see what we are seeing. And what we are seeing here, this is what we call the interface. Okay, so this operating system, it does so many things on your laptop. Okay, when you are running a program, it is the job of the operating system to assign that program what is known as the processor. So for the program to run, it requires the processor. For the program to run, it requires memory. So the job of this operating system is to assign the programs that we are running, okay, the resources. The programs are able to run on your laptop. It is because of the operating system. Okay, so Linux is also another operating system, okay, created in 1991. So Linux, as I said, it is open source, meaning that you can get that Linux if you are very, very good at programming and come up with your own Linux, okay? So it is fast, reliable, and very, very small. And of course, these are very good characteristics of an operating system. It must be fast. So if you're going to come up with this operating system, which is very, very slow, which is going to be unreliable, no one is going to buy it. So an operating system has to be fast. It has to be reliable. It has to be small, meaning that it requires only little hardware resources to run. So here, when you say hardware resources, we are meaning the CPU, which is the processor, the RAM, and others. Okay. So Linux is used everywhere now. Linux is used starting from wristwatches, up to supercomputers, as you can see. Linux is very, very important. You find that even some countries like Germany, they have now adopted Linux to be used in their government. They no longer want to be using Windows. Okay, so Linux is really the future. And of course, this was designed to be connected to the network. Okay. It was designed to be used as a network operating system. Okay. And then we also have what is known as Linux distribution. So Linux distribution has to do with the packaging. All right. So this company is going to get this Linux and they're going to create their own program that is called a distribution. Okay. So we have got different distributions. We have Ubuntu, Kali Linux, okay, CentOS, Fedora, all those are Linux distributions. Okay, they differ according to the programs that come with different distributions, the tools. Okay, the value of Linux. Okay, so you can see that Linux is often the choice of an operating system being used in a SOC. Why? there are so many reasons, and these reasons are here. The first one is that Linux is open source. So it means that you, when you're running a source, you can get this Linux, and change it to suit your needs, okay? The other reason is that the Linux CLI command line is really very, very powerful, So you can use this powerful CLI to perform any tasks that you want on a system which is very, very far, okay? And then the other reason is that the user on Linux has more control over the operating system. And this user is what we call the super user or the root user. So he's able to change anything, okay? And then the last reason is that, of course, this is a network operating system, Therefore, it is better, to be used as a network communication control. So those are the values of Linux. All right. So Linux in a SOC. So you can see that Linux can give us a number of features in the SOC. We can come up with whatever design we want, the design which is going to be perfect for us as cybersecurity analysts. Okay. So here, this is square. Okay. This is your tool as cybersecurity analyst. So this is a square. It is a special version of Linux, in a tool called Security Onion. Okay. Now, this Security Onion is an open source which has a suite of tools that work together, and we'll be using these very tools in the labs where we are going. So, Square, how it works, what you see here is the status, and the colors here, they mean a lot. So we have got the colors from light yellow to red. These colors do indicate the seriousness of an alert that has been received. So this same square, it is connected to different sensors. For example, the intrusion prevention system, the firewall. So what they do is, those sensors you have in your organization, they do detect some intrusions. Once they do that, then they send alerts here. And these alerts are categorized according to the colors. So red, it means that this alert is really serious. So this is the status, okay, the first column. The second column is count. So count has to do with, counting the same event coming from the same source, going to the same destination. How many times has that happened? This one, count, okay? And
reports are good.
Hello? And then these are sensors. So you can see these are sensors, different types of sensors. So this is where we can have, different intrusion prevention systems, host-based intrusion prevention systems, and so on. And then alert ID, which is used to identify the alert, the date, the time when the alert was received. source IP, the IP address where the alert was coming from, source port, this is a source port number, okay? So of course, the reason why we are able to run or to connect so many devices on your laptop, it is because of these same source port numbers, these, okay? So when you run an internet application, a source port number automatically will be generated. So when that request goes to the internet, when it's coming back, it has to come back to that same number. You know, this is the reason why you can open so many applications, internet applications, okay? This is the destination IP, okay? And then destination port number. So you can see that the destination port numbers, most of the time they have fixed numbers. There we have well-known ports and so on. So you see, when you see 80, it means that this traffic has got to do with web services. We're going to look at these ports. Okay, and then the event message. Now here, you're going to have information, you know, about what triggered the alert. You know, we're going to go into detail, you know. So it is from here where you show your skills as an analyst, proving whether this alert is an incident or it's not. Okay, all right. So we have a list of tools that we can have on a SOC. We have what are known as network packet capture software. Okay, so this is, you know, we have different, we call these tools sometimes as, you know, packet sniffers. Okay, so we're going to look at the Wireshark. So the Wireshark is one of the packet sniffers too. So what it does is it captures the traffic in the organization. No wonder in certain institutions, you know, you're not allowed to have a Wireshark on your laptop because you can be capturing the traffic of the organization. Now, this tool here, you can see here, it is really a crucial tool because, you know, it makes it possible for you as an analyst to observe and understand every detail of a network transaction. Okay, so one of the tools that we have is Wireshark. Okay, it's a graphical user interface tool. Okay, the other one is TCP dump. That one is a command line tool. Okay, so you can see here Wireshark. Very, very important that you know this tool to the fullest. Then the other tool that you can have is malware analysis tools. Okay, so these, they let you run and observe malware execution without the risk of infecting your laptop. Okay, so it is from here where you can truly understand the behavior of a virus, okay, of a worm, of a Trojan horse, and so on. Okay, we also have intrusion detection systems. So these are systems which are able to detect malicious traffic. Okay, so you find that it can work hand in hand with the firewall, whereby it can detect malicious traffic and send information to the firewall to block that traffic. Or we can use the intrusion detection system to really find out whether the intrusion prevention system is working. So here I've got two tools. The intrusion detection system only detects malicious traffic. And then the intrusion prevention system detects and prevent. Okay, So we can have these tools side by side, all right? And, if the same traffic is able to pass through the IPS, and then the IPS is not doing anything, but if the same traffic passes through the IDS and then the IDS detects something, then from there we can be able to know that there's something wrong with our intrusion prevention system. Okay. So the other two that we can have, are firewalls. Okay. So we have different types of firewalls. We have software-based firewalls and hardware-based firewalls. So the firewall that you have on your laptop, it's called a software-based firewall. Now, what is a firewall? The word firewall, it was used a long time ago in buildings, whereby they would build a wall, and that wall couldn't allow fire, to move to the other building, okay? But in our case, we use the firewall to filter the traffic that is coming to the organization. That is, we can say, as an institution, any traffic which is coming from the internet, we need to block. It has to be blocked and dropped. But any traffic which went to the internet and it's coming back, it has to be allowed, okay? That is the work of the firewall. And of course, to block and to allow traffic, it uses what are known as the rules. Okay, so we have software-based firewall and standalone or hardware-based firewall. So this is a device which is a firewall on its own. Okay, that's how it works. We also have log managers. Okay, so the logs, these are the messages that the systems, do generate, and whatever is happening to the system is being recorded. So such messages are called the logs. Okay, now, if the organization is very big, it means that a number of logs will be generated. All right. So as an analyst, very, very important that you read the logs. We are going to talk about that in future, because it is from the logs that you can be able to know that your organization is about to be hacked. Because once you check the logs, you can be able to see that maybe someone, tried this, fake password a number of times. That indicates that somebody wanted to hack your organization. So we get a lot of information from the logs about what is happening in the organization. So very, very important that we have the log managers. So all the logs, they are collected and sent to the log manager. And then it is now you will be able to be, analyzing those logs. Then the other tool that we have is security information and event management system. Okay, this is a very, very important system because it is able to provide real-time analysis of alerts and log entries generated by network appliances such as the IDS and the firewalls. Okay, ticketing system, of course, this is a system that we can use, for assignments, editing, recording the events. Okay, so the ticketing system, it puts those alerts that we're receiving in an order such that we can't skip any of the alerts that have been received. Okay, all right, Linux tools. All right, so we have an operating system called Kali Linux. Okay, this is Linux, of course, and it is a tool that is used in what is known as penetration testing or pen testing, or what is known as ethical hacking. So ethical hacking is also very, very important, because here you hack your organization. You hack your organization to find out the weaknesses, okay? So for ethical hackers or pen testers, this Kali Linux was made for you. But the unfortunate part is that hackers also use the same to hack institutions. So it has so many tools. For example, packet generators. So packet generators, these are the tools which are able to create packets, malicious packets, or packets that we can be able to test the systems of the organization, okay? Port scanners. So port scanners, these are the tools that are checking for what are the ports that are open on a system, because the ports are related to the services that are running. We're going to look at the port numbers with their respective services. So port scanners, once they know the ports that are open, from there now, the attackers can go further and find out what are some of the vulnerabilities or the weaknesses associated with those services, okay? And then proof of concept exploits, okay? All right, so here you can see we have information gathering tools, vulnerability assessment tools, So you can see that Kali Linux here has a lot of tools, which you can use for pen testing. That is for hacking your organization to find out the weaknesses. So once you have found out the weaknesses, then you can be able to advise your organization what to do, okay? That is very, very important, okay? Section 2, working in the Linux shell. Okay. All right. So on a Linux machine, you can be able to communicate with the operating system either using a command line, CLI, or GUI. Okay. Of course, Linux, it starts most of the time with the GUI by default, okay? But in the end, you can be able to access the CLI. And in Linux, you find that we have a number of terminal emulators, which are called by different names: Terminator, eTerm, Xterm, Console, Genome, Terminal, and so on. All right, so this is what is known as the CLI. Okay, so here, this is where you run the commands. By running the commands, you can be able to manage the Linux system. Of course, for you to know this, for you to run Linux with commands, you must know these commands, and you're going to know them, at the end of this module. Okay, so these are the commands that you can run here. So the thing is, once you run the command, the command goes to the operating system, all right? And then the operating system has to do what the command is telling it to do, okay? So if you see here, list-l documents, once you enter this command, then these are the results, and so on. All right. So if you want to move or rename files and directories, this is the command, mv, move. You know, these guys, they made our lives easy because, have you seen, mv, it is coming from the very word what? Move. So mv command is for moving or renaming. Okay. Change mode. So this command is for modifying file permissions. Okay. Change on, changing the ownership of a file. Okay. DD copies data from an input to an output. PWD, this command displays the name of the current directory. So very, very important that you know these commands, and you can know these commands by practicing. The command PS lists the processes that are currently running in the system. Okay. CU simulates a login as another user or to become a super user. Okay. Sudo. So when you start any command with sudo, it means you want to run that command as a super user, okay, or as a root user. Okay. Grep. This command is used to search for specific strings of characters within a file or other command outputs. Okay. If config. Remember, on Windows, what was I using? I was using IP config. Okay. So in Windows, we use if config to display or configure network card related information. Okay. apt-get, it is used to install, configure, and remove packages on Debian. Okay. iwconfig, used to display or configure wireless network card related information. Shut down, for shutting down the system. Okay. passwd, to change the password. The cat command, we use the cat command to list the contents of a file. Okay. Man command, this is a very, very important command. This command here, it is used to know a lot about a particular command. For instance, if you want to know more about the sudo command, what you type on the prompt is man followed by sudo. If you want to know more about the cat command, you type man, then cat. So the man command is really important. File and directory commands, okay? So this is list, ls. We use this command to display the files inside a directory. So a directory is the same as a folder in Windows, okay? CD, okay, changes the current directory. If you want to move from one folder to another folder, use this command cd, okay? If you want to create a directory, this command, mkdir, for creating directory, For copying files from source to destination is cp, copy. It has been changed. Oh. Okay. Okay, so this is the CP. MV, moving. You see? RM, removing files. Okay. We looked at grep and cat already. Now, very, very important that you know these commands. As I said, Linux is really the operating system of the future. Okay. Working with text files. So, of course, Linux has different types of text editors. All right. Some text editors are GUI, others just use command lines. Okay. So, you know, it is up to you, whichever text editor you want to use, you know. So we have V, Vim, Nano. Those are different types of text editor. So this is a text editor here, Nano. Okay. All right. So you can see it is. So you can see here, it lacks the graphical support. Okay. And it can be controlled with what? The keyboard. So when you're working with Nano as a text editor, you have to, you know, use the keyboard. Now, why is it that the text files are important in Linux? The reason is simple. Because everything in Linux is treated as a file. Okay, so the memory is treated as a file. The disks, the monitor, okay, and other directories are treated as files. So the thing is, once you make any changes on the file, then that is going to also affect that particular service. Okay, all right. All right, so this is the lab we're going to do, very, very important, and also this is another lab that we're going to do. Section 3, Linux servers and clients. All right, so here, these are what we call clients. You know, your laptop is a client, your PC is a client. It is always asking from the server, okay? The server, this is a computer. What it does is to provide the answers to the servers, okay? So when you were creating your Facebook account, okay, you were doing that on the servers of Facebook, okay? Next time you go to the internet cafe, you log into your account, that information is on the servers of Facebook. That's where it sits, okay? So a server is a computer, but it is a powerful computer, you know, because a server serves a number of clients. It means that it must have a powerful CPU. It must have a powerful RAM as compared to these clients that we have. So this is what we call client-server communication, okay? So the client will be asking from the server, and then the server has to provide, okay? That's how it works, okay? Servers, services, and their ports, okay? So these are what we call well-known port numbers, and you must know these port numbers. So when you see a port number 20 or 21, that deals with the file transfer protocol. So this is the protocol that is involved when you are transmitting a file, okay? And then 22, it deals with a protocol called secure shell. What is secure shell? So this is what we use when you want to manage a device which is at a distance, okay? 23, Telnet. So Telnet, this is a service also that we use when we want to manage a device which is very far. Now, the difference between Secure Shell and Telnet is that everything you are dealing with in Telnet is transmitted in clear text. So when this information has been intercepted, someone can be able to read that information. And then anything you do with Secure Shell is encrypted. That is, even though this information has been intercepted, you can't read that information unless you decrypt the message. Okay. 25, when you are sending an email, the protocol or the service which is involved there is simple mail transfer protocol. Okay. 53 deals with domain name system. What is domain name system? This is a server that matches names to their IP addresses. How things work on the internet is, of course, anything which is on the internet must have a unique IP address. Okay, but with us humans, we are very poor at memorizing the numbers. Okay, therefore we are good at knowing the words. So there's no need, if I want to to go to Google or to Google, all right, to know the IP address. All what I need to do, all I need to know is the name. So once I write Google, that word goes to the DNS server. The DNS server matches the word to the IP address. That's when now the information goes to the servers of Google, okay? Then we have 67, 68. These are port numbers that are used for dynamic host configuration protocol. This is the protocol that we use to assign the IP addresses automatically in your organization. You see, in your organization, the computers can be given the IP addresses manually or statically. That is, you go to this computer, you give it the IP address, the subnet mask, and the default gateway. From there, you move on. I mean, that is not a good idea. So very, very important that you configure DHCP, which is going to give the IP addresses to the systems automatically. Okay. All right. And then 69 is used for a trivial file transfer protocol. Now, the badness with this is that, it is not secure, okay? 80 deals with hypertext transfer protocol, the web, okay? 110 deals with POP3. So when you are receiving an email, this is the protocol that is involved, okay? 123 deals with network time protocol. The job of network time protocol is to ensure that all the devices in your organization have the same time. This is very, very important, because when the devices in the organization are running on different time, and when your organization is hacked, you won't be able to correlate the events, what happened. Okay. Then we have 143. This is for IMAP. This is also another protocol that is involved when you are receiving an email. Now, the difference between POP3 and IMAP is that with POP3, when you receive that email, the email is deleted from the server. okay? But with IMAP, even though you receive this email, the email will still be on the server, okay? 161 and 162, this is called the Simple Network Management Protocol. This is the protocol which is used to manage a network when the network is, very, very big. All right. So how this protocol works is that you are going to have some agents on each and every devices, so that anything that is happening, the devices, you'll be able to receive a message on the manager. So when the system is down, then you'll be able to know that such and such system is down, okay, because you'll be alerted, okay. All right, 443, so this is HTTP secure, what you do with this is encrypted. When you use this, whatever you're dealing with is not encrypted. So this is the one which is recommended. Okay. All right. So as I was saying, that when you open up the browser, a source port number is generated. Okay, that is the source port number. And when you go, since this is the web, it means that you'll be going to port 80. So the destination port will be what? Port 80. Okay, so when the server answers, the answer will go to the very source port number. Okay, that's how things work. So the client will ask for the resources from the server, and then the server will be able to provide the resources. Okay, so that's a lab we're going to do. Section 4, basic server administration. Okay, so I said it earlier on that anything that we have in Linux, is treated as a file. So this is one of the server files, okay? So if you are going to make any changes to what is here, that is going to change how the server is going to work. And this is also the configuration file for NTP. Okay. All right. Hardening devices. What is hardening a device? All right. So hardening devices, this is a method that we use to make the devices secure. Okay. So when we are hardening the devices, we are making sure that the operating system is up to date. It has been patched. We are making sure that only necessary services are running on those systems. We are making sure that they have a strong password and so on. Okay. So such a process is called hardening, hardening a device. All right. So we have the following basic practices for hardening devices. One, we have to ensure physical security. Okay. Physical security, it means that, the server room in your organization is well protected. There is no way that, everyone must have access to the server room. You make sure that you have CCTV. You can also have motion detectors there. You can also have maybe, biometric systems. That is, if someone wants to have access to the server. Another situation which happened here in Zambia when we had elections whereby somebody, sneaked into the server room. That is, there was no physical security there. Okay. So you must ensure physical security. You minimize installed packages. Very, very important. So the services that are not using must be removed from the systems. Okay. So you disable unused services. You see, make sure that you use SSH. You ensure that the systems in your organization are updated. So as I said, you find that the software that we use, the operating system that we use is made up of millions of lines of code. And the coding is done by us, humans. So we are bound to make a mistake. And once the mistake has been made, that creates what is known as a vulnerability, a weakness. So once it has been discovered that there is a weakness, then the company is going to release a patch. So you have to patch, you have to update. You must disable USB auto detection. Okay, there's a lot that you can do. To make it in such a way that people are not, stealing information through USB drive. You can disable USB drive. Okay. If you want people not to be emailing very, very important information, you can do that. There are different tools that you use, whereby if it detects that this very, very important information is about to leave the organization, then it can be able to block that. Then you enforce strong passwords. How do you enforce? So the thing is, the network admin has to do this. You saw when you were creating your account, you were forced that your password must have 8 characters. It must have capital letters. It must have smaller letters, at least a number, at least a special character. Okay, that is enforcing strong passwords, what you did. Okay, force periodic password changes. We had this feature on our platform, the NetAcad platform, whereby time and again they will tell us that, your password is expiring, you have to change. Okay, and then keep users from using what? Odd passwords. Okay, so that's how you harden the devices. Okay. Monitoring service logs, as I said, logs are messages, about what is happening to the system. So very, very important that as a network admin, you must be able to read and understand these logs. So in Linux, the logs can be categorized as application logs, the logs coming from applications, event logs, logs coming from the events, service logs, the logs coming from the services that we are running, and then system logs. These are logs coming from the device drivers and the operating system itself. So you can see that some logs, they do contain information about daemons that are running in Linux. So a daemon, this is a process which is running in the background, okay? And it doesn't need any user interaction at all. So in Linux, what log files do we have? So this is the path var log messages. So this contains informational and non-critical system messages. And then if we have var log onth.log, this is where we store authentication related events. Okay, that is in Debian and Ubuntu. But in Red Hat and CentOS, we store such information in what? var log secure. Okay, and then var log boot.log, this is where we store boot related information related to Linux when it is starting. Okay, and then the D message, it contains kernel ring buffer messages. Okay, and then kernel.log, it contains information logged by the kernel. And then the cron, this contains information related to the tasks that have been automated. And then you can see we have MySQL.log and MySQL. This is where we store MySQL related information. Okay. All right. So that's how it is. Okay. Moving further, we will look at the file system which Linux uses. So you find that out there we have different kinds of file systems. These, they differ in terms of the speed. Okay, how fast is this file system? How flexible? Okay, how secure? The size, structure, and so on. Okay, so you find that Linux supported the following file systems. Second, extended file system. So this is the default file system used in so many Linux distributions, until it was replaced by extension 3. Okay, so extension 3 uses a system called a journal. Okay, so this is a technique which minimizes the risk of losing information on a file. Okay, so you find that some people suggested a number of features to be added to extension 3. Others were against that idea. Okay, so those new features were added to a fourth extended file system. Okay, because some programmers were saying these new features, they are going to destabilize the stability of the third extension. Okay, then we have the network file system. So this is a network-based file system which allows file access over the network. And then we have the compact disk file system. This, of course, was created specifically for the optic disk media. And then the swap file system. So you find that on your laptop, when you do have unlimited RAM, you find that some information will be taken to the hard drive, So, and then when the RAM frees up, then that information will be taken back to the RAM, Okay, so that is what is known as the swap file system. Okay, and then in Macintosh computers, we use the hierarchical file system plus. Okay, and then currently these systems, they use an updated file system called the Apple file system. We also have the master boot recorder. So this is the first sector on a disk, okay? And it contains the information that we can use, to load certain functions or to load even the operating system itself, okay? And then the term like mount, okay, very, very important, okay? We are talking about mounting when we are petitioning the hard drive, okay? To petition a hard drive is to divide the hard drive into separate petitions. So if you see on your laptop, you have the C drive, the D drive, and so on. So that hard drive was petitioned into those sectors. Okay. Linux roles and file permissions. So this is really the feature which makes Linux not to be vulnerable to malware. It is the file permissions. So let us, and of course, we have permissions such as read. Okay, that is, you can just read the file. Write means that you can, edit the file. I think you have seen that sometimes you have this PDF, where you can't change anything. It means that you don't have the permissions to write. So these are the permissions: read, write, and execute. Okay. So if you go to the terminal and then you type this command, list-l, this is a file. Okay. So once you press enter, you're going to have these permissions. Okay. So have you seen here, this dash, it means that you are dealing with a file. Okay. And then if here we have D, it means that we are dealing with a directory. So the first three permissions, these are related to a user. So the user will be able to read, write, and execute. The next three permissions, these are related to a group. Okay. So you find that your laptop can be placed maybe in a certain group. So in the group, we only have read, write. We don't have execute. And then the last three permissions are for others. So others can only read. Okay. All right. So that's how it is. So you can see this here, this is the user, analyst, and then the group is staff. This here is the file size, 253 bytes. Okay. And then we have the date and time. And then this is the file name. Okay. So very, very important that you know that. Okay. So this is what I was talking about. The dash means it's a file. The D means it's a directory, a folder. Then the first three permissions, these are related to the user. The next three, the group. So a user can be put in a particular group. And then these are others. Okay. All right. So you see These same permissions can be represented using decimal numbers. So when we have the dashes, it means no access at all. 1, it is for execute only. 2 is assigned to what? Write only, okay? So 3, it is for write and execute. The number 4, it is for what? Reading only. So 5, it means read and execute. 6, read and write. And then 7, it means that you have got all the permissions. Read, write, and execute. Okay. Very, very important to know that. Okay. Hard links and symbolic links. So a hard link is another file that points to the same location as the original file. We use this command ln to create a hard link. Okay, so you can see here ln, it means I'm creating the hard link. Okay, now you can also list, you try to see what is in space. Okay, in short, we are going to do this in the lab, but the command echo, when you say echo testing hard link, okay, and then you are pointing to space, here it means that you are adding this sentence to the text. Okay, here it means that you're just listing what is in space. Okay, then you can also use this command for removing. The more command can show you what is in the file. Okay, all right. We also have the symbolic link, okay, or the soft link, okay. When creating this, it's ln, and you have to include s to make it to be a soft link. You know, the difference between these two is that locating the hard link is difficulty, whereas locating the soft link is easy. And then also hard links only works on the system where they've been created. So when you have got this, hard link, you can't move it over to another, system, a different system. Okay. And then you can see also here, hard links cannot link to a directory, but symbolic links can. And we'll do most of those in the lab. Okay. I think this will be our last section, working with the Linux GUI. Okay. So we can manage a Linux machine either using CLI or using GUI, and this GUI in Linux is called X or X11. Okay, so this is the GUI, the graphical user interface for Linux, and this is the genome, and then this is KDE. Okay, so you can see, Linux, it's opposite. We have the taskbar up there, okay? And the Ubuntu dock here, okay? And then the apps are here, okay? So this is how, it is a little bit different, from Windows. Okay. All right. Working on a Linux host. So if you want to install or if you want to update the Linux operating system, this is the command. Of course, you have to be a super user. That's why you have to start as sudo apt-get. What do you want to do? Update. You just have to type update, and it's going to easily update. If you want to upgrade, again, sudo apt-get upgrade, and quickly it is going to upgrade. Okay. So this is how you install and run applications on the Linux host. Okay. Okay, so that's how you do it. All right. Or if you want, you can use the software updater app there. Okay. Just
Hello.
yes.
Yes, you can just go back to the previous slide. The other one. It's on the update upgrade. The previous one, the command line.
Okay. Yeah.
Yes. So are we supposed to type everything like sudo apt-get, then you type everything like upgrade or update?
Yes, of course. Yes, of course. So sudo apt-get and then upgrade. You know, in other systems, anyway, I haven't tried it on the Ubuntu, because others, you can just type su and then you press the tab key. The tab key is going to complete the command, okay? And then apt-get and so on. You have to type in all these. Now, for you to update a system, you have to be a super user. You know?
Okay.
Therefore, if you want to run a command as a super user, in the beginning, you must type this command, sudo apt-get and then update. Then you'll be asked for the password, and then you key in the password. If you want to upgrade the cell, as I said, all these commands, you are going to know them, and you can only know them by practicing. We have a number of labs that we are going to do. Okay.
Okay. Thank you.
Yeah. So just like what we saw on Windows, in Linux, we also have the process. Okay. So the process is just the program which is executing. Okay. And then forking, this is just the method which Linux uses to create a copy of the process. Okay. We looked at these commands, the PS, which is used to list the processes that are running on the Linux machine. And then the top command is used to list running processes. But unlike PS, the top command keeps displaying running processes dynamically, automatically. And then we have also Q. If you want to stop the process, we can use the command Q. Okay. So this is the top command, how it works. All right. So malware on Linux host, you know, some people do say that Linux, you know, is not affected by malware. You know, the fact is that it is affected, but it is not affected in such a way as, in the way Windows is affected. Why? It is because of the file system of Linux and those permissions that you saw. Okay, but you find that it is Linux is vulnerable to attacks, you know. Okay. Then you see, once the hackers have hacked your system, then they have to plant what is known as a rootkit. Okay. So this rootkit is going to be manipulating the processes such that even though when you are scanning your system, you can't be able to detect the rootkit. When you switch off your system, you start it, you know, the rootkit also starts, okay? So this is really an attack which is difficult to detect, you know, because it is working with the operating system. So how do you check for rootkits on Linux? Use the command sudo space dash / and then the command check rootkit. Once you run this command, then you can be able to find out whether your system is infected or it is not. Okay. Piping commands. So when you are piping a command, what you are doing is that you are running this command, the output of the command you are running first is going to be the input of the second command, okay? That is what we call piping. So in our case here, you can see we want to list the files that we have. These have been listed. So you can list and then you pipe. So meaning the output from here will be the input for this second command, okay? So once you say grep host, so all this will be the input for this command and the output, of course, will be generated, okay? So this process is called piping the commands, okay? You pipe the commands. All right, so you can see there is the video demonstration here on applications, rootkits, and piping commands. So the thing is, you have read, but you didn't understand. Therefore, you can play, you can play this video and, you know, and be able to understand. This is the goodness of the materials that we have. So they have videos on concepts that may be difficult for you to understand. Do we have questions on Linux? Okay, so this is really very, very important. Anyway, I thank you for attending. I really appreciate. I will see you tomorrow.
I have a question.
Yes.
So what's the recommended Linux that we can use for practice? Are we getting Kali or because quite a number of versions?
Yes, yes. We'll be using the workstation.
Or the workstation?
Yes, the labs are based on the workstation. So for now, using the workstation. Okay, so once you have been baked, you know, then you can now start using Kali. That is, if you want to go into ethical hacking or pen testing. But I would recommend that you have to do pen testing or ethical hacking. There are some websites such as CyberOPS, where you can watch some videos on pen testing for free. But when you want the labs, you can pay. Okay, so CyberOPS.it. Okay, the other one is Pluralsight, but I don't know whether you have to pay on Pro side. But what I know is that on Cyber IT, I don't have to pay anything. Okay, so when you are into ethical hacking or pen testing, that's when you're going to start using Kali Linux. But for now, since we are just starting, we'll be using the workstation. So when you are baked now, that's when you can go to these other distributors. Okay, but the good news is once you know this on one type, then it will be easier for you to do the same on the different distributor. Okay, do we have questions? I'm happy to see that people have started writing exams. Anyway, good night. I'll see you tomorrow.
Good night.
Good night. Good night.